you can see on the screen, we have the data and then the sources. So we have the digital elevation model. How does this add or contribute to landfill site selection? For dumping refuse or refuse, we can be dumping refuse where we have ILE area, because when you have rainfall, it's slide down to a hand, so it will flood it back to lowlands. You get my point now. So we are taking the detailed elevation model as part of the first criteria. Are you with me? Now the second one is the distance from river. Your river, you have to be very careful, because if you are dumping refuse near your river bank, let's say there's an increase in river level, there's probability that the river will flood all those refuges, and then it can cause blockage, and then flooding events will occur within that environment. So we have to consider the river, the distance from the river, that is offset from the rivers within the study area. ILE IFE is our study area. Are we together? Now, the third criterion is the distance from road. The road accessibility. When we're trying to work with the best location for landfill, we have to put in place road accessibility, because let's say you want to park your refuse, like the vehicle wants to park the refuse, and then it's not having access to where you guys are dumping refuse. That would be a problem, right? So we have to put the road into consideration, and it mustn't be that too close to the road because of air pollution. Do you get my point? Because it will be smelling. Let's say they're dumping main refuse along Ife-Ibadan Expressway. You get my point? And vehicles are passing. They'll be like, oh my God, what's smelling with this area? Do you get my point? So we have to consider those factors altogether. So now, the fourth is the distance from residential area. Where people reside. You get my point? It's not ideal to dump refuse near residential places, because basically air pollution issue. So we are taking this residential criterion as part of the data to use for the landfill selection tax. And then the second to the last is the slope. We have to consider the slope of the area, because ask of your welcome, sir. Yeah, boss. So we have to consider the slope. Every slope greater than 15% is not always good because of landslide, based on scientific knowledge. Are we together? So we have to reclassify our slope to fit in that particular ranking or the scale we are making use of. Are we together? So I will show you what the ranking is all about. So as you can see on the screen, we have data I used, which includes the dam, the distance from river, the distance from road, the distance from residential area, slope, soil. Sometimes you can have geological data, but based on the fact that I was unable to get that, you get my point. For the entire ILE IFE, we only have a single geological or feature layer, which is very poor. But let's assume I'm using the entire Nigeria now. I'm going to have a lot of geological data for use. Did you get my point? But based on the fact that my study area is small out of the entire area, did you get my point? So I have a limited data on that. So that was the reason I couldn't make use of the geological data altogether. So now, and I have the different sources pertaining to each data. So if you want to download your data elevation model, there are different ways you can download. Like I have explained in the past tutorials we had. You can use your GIS, which is the Earth Explorer, or you can decide to use your GoGet engine to derive your code. That is what I was working with Adebola the last maybe is it not day before yesterday? Like I was trying to achieve a digital elevation model of Oshogbo using the GoGet engine. It's working on watershed delineation analysis. So that is our project. So there are different methods you can use to download your digital elevation model. Like I said, you can use the Earth Explorer. At the same time, you can use a GoGet engine. Wumito is working on something related to that. I think your own is Landsat. Yeah, you want to use GoGet engine to download Landsat data. Alright, so the distance from road, as you have on the screen here, I have BB bike extract. So in this case, the OSM data is freely available publicly, and you can all have access to that. And just define your study area depending on what you're working on, and with that, you're good to go. The same applies to the road. And then the residential area. In this case, we are going to make use of Landsat data because you're going to perform your land use land cover to get the residential areas. Like if you're familiar with urban sprawl analysis, you know you're working pertaining to the built up alone. You're less concerned about other vegetation or whatever. So in this case, it's something related to urban sprawl. So you're just interested in the built up area alone. So you just extract the grid code responsible for the built up area, and then you can now normalize or put it on the same scale as the ranking system you had earlier. So the soil data, which is the last, can be downloaded from this website, the foul soil data. So it's for the entire world. All these are for the entire world. The soil, the geological map. The geological map was not included because for ILE IFE, I only have a single unit. I have geological units for the entire ILE IFE. So that was the reason why I neglected that. So as you can see, the research blah 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 parameters such as the topographical expression, there's elevation, slope, hydrological distance from road, socioeconomical data, distance from residentials, and to evaluate the suitable disposal site in LA IFE. So all these are just stories, and then you can read them up. But let me just quickly go to where it's of importance or where it's of use. So the elevation data, you have to reclassify your elevation data to suit your own purpose. I'm using 5 ranking system in this case, in which my rank 1 goes to not suitable, rank 2 less suitable, rank 3 moderately suitable, rank 4 suitable, and rank 5 is highly suitable altogether. So this is the ranking system I'm using. Some people can decide to use 3 ranking system. That is, 1 will go to not suitable, 2 will go to moderate suitable, and 3 will go to what? Highly suitable. Did you get my point? That is their whole. But as we are using 5 ranking system. So now, as you know that elevation, if you want to reclass the elevation, your elevation is all about like variation in heights over the study area you're working with. So for this case, ILE IFE is having like 649 meter as the highest elevation value, and the lowest is 68 meter, and it's located along the southern part of the region where the 649 meter is the highest elevation, located in the northeast part of my study area. So those are the things you have to put in place when you're writing your methodology or report. So as you can see, the suitability class, I have not suitable, less suitable, moderately suitable, suitable, and highly suitable. Normally, the best zone is this highly suitable. Are we together? This is the main one we are after. Are we together? Everywhere is suitable, but we just need the best out of all those suitability, whatever. So now, you can see the elevation. When I reclass this, I reclassify my raster, raster, into 5 classes. The first class is, the first rank is equivalent to 68 to 166 meter. It depends on your choice. Did you get my point? When I reclass, I make use of, natural gene. In my ArcGIS straight away, it's going to reclassify based on its natural genes. So like, everything is equal. You get my point now. So I have all those values included here. So 68 meter to 166 meter is considered to be highly suitable for this task. Altogether, you can decide your own to be maybe 68 to 180. You get my point now. So it depends on your own choice. Altogether with me. So alright, so you can just reclass that until you have the highest elevation up here, and then the lowest, which is the one here, altogether. So that's for elevation. And then the same thing, as you can see now, this is the map of elevation within ILE IFE. You can see the one corresponds for what? Here, not suitable. So anywhere I see this color 1, red, so all these areas are not suitable. Are we together now? So that's all about that. So these are each criterion. So everything altogether is multi-criteria. You get my point? So this is a multi-criteria decision analysis. Are we together? So that is for the elevation. So you can see the slope. Like we did for elevation, you're going to repeat the same thing for slope. You're going to reclass it into 5 ranking system, whatever. So now, I told you any slope greater than 15% is considered to be bad, right? So you have to make sure that my not suitable is corresponding to where I have that slope to be very bad. Did you get my point now? So any other values you can reclassify it based on your own choice, and this is what I have. When my slope is 0, so that means it's less suitable. I don't want to use, because normally the lowest slope here should correspond to highly suitable. Do you get my point? The reason why I didn't use it, because what about those that are building house? Do you get my point? You have to consider them, because we can't say that okay, every land here is for dumping refuse. What about the buildings? So you have to consider that. So that means every slope within the 0 to 1 is good for maybe buildings like infrastructures and stuff like that, because they won't be experiencing issue with landslide and whatever. And the 1.78 to 4.15 slope is moderately suitable. So where I put my highly suitable for this tax is 4 to 8. That is, every slope percentage between 4% to 8% is considered to be highly suitable for this tax altogether now. So it depends on your choice. So that's what I have there. And then this is the slope map. You can see the color, the one, as the visualization of it. So now the distance from the river. It's very simple. This thing is very simple. Once you understand the concept, you can do for any other thing altogether. Now, the distance from river, we have your river in form of vector, right? In form of lines altogether. So you have to let us know that, okay, right, you want to offset from the center line of the river, right? 0 to maybe 0 meter is from the center to 200 offsets to left and right. It's very bad altogether. You can decide that you want to use your own to be 0 to 300 altogether with me. So the not suitable is 0 to 200. That is for my own purpose. So my 200 to 500 is less suitable, and then 500 to 1000 is moderately suitable, and 1000 to 15 is suitable, and then you can see greater than 1500 meter from the river is highly suitable. It's very far away from the river, so we can't be dumping refuse where we have or very close to the river. You get my points now. So that's all about the reclass stream table. As you can see now, this are the river. You can see the river is mostly populated on the north part of the study area. So, and then some are within the southern part, like that. So you can see the road also. Waste transportation is an issue. Blah blah blah. That's just theory. But the concept here is that my consideration is that I'm considering every type of roads in Nigeria. Some people can consider federal road alone. You get my point? Some people can consider state road and local road. I consider every roads altogether now. Every road was considered. The federal, the state, and the local roads. So I use all the road present within the study area for my analysis. So now the buffer zone is like from the middle of your road is 0 from the middle, 200 meter left and right. It's not suitable altogether, because at least let's say this is my road and 200 meter, you can still see 200 meter. You get my point? Like from the middle of the road, you can still see 200 meter, because we still see houses that are very close to the road sometimes. So it's not ideal you dumping refuse to where you have like your road closer to where you dumping refuse. It's very bad. So that was the reason why I was doing this reclassification to range between 0 to 200. So to be equivalent to my not suitable. Suitability altogether. It depends on your choice. You can say 0 to 50 meter is not suitable. You get my point now. So depending on your choice and the entire study area you're working with altogether. So now my 200 to 500 is moderately suitable. You get my point? And if you notice something, I said my 500 to 1000 distance is highly suitable. Why? Because when you're dumping your refuse, it must not be that too far from the road. You get my point? And it mustn't be too close to the road altogether. So that was the reason why I have to scale that to the middle. The highly suitable, I have to place that at the middle. So it's not that too close and it's not that too far. So the highly suitability is in between the scale altogether. So do you have any question? Okay, me. You have any question? Okay, right. So now my 1000 to 15 is suitable, and then greater than 1500 distance is less suitable, because if you have like 1500 meters away from your route, it's too far now because I want to go and dump refuse. What are you telling me? Did you get my point now? So all those areas, they are less suitable for dumping refuse. That's each criterion has been reclassified altogether now. So this, as you can see now, you can see the roads here. So the number one, the Greek code 1 is equivalent. You can see the Greek code 1 is almost populated within the built-up area of Ife. Look at that. So it means those areas are not suitable for stuff like that altogether. So now you can see 3, which is the moderately suitable. You can see the color and everything like that. So, and then the last is the distance from residential area. Before you can do this, you need to get some tax done. So your mic. Welcome, sir. Now you need to do some things. Antonia, you're on. I cite you. Yeah, you need to get some things done first because you can't just arrive at a residential area altogether. Reason is that you have built up areas like buildings, right? Now, how do I get all these things out? I don't like using the shapefile for buildings. I prefer using my residential area from my land use land cover. Do you get my point? When you do your classification in land use land cover, you're going to have different classes. Abi, you have built up, you have water, you have forests, shrubs, farmlands, what is again, baylands, rocks, and many more features you can see within your study area. Altogether. Yeah. So that is all about that. So, but in this case, after you're done with your land use land cover classification, you just extract your built up area alone. Altogether. You just extract that one only, built up. Maybe it is good one. You just extract that one out. Get my point? So after you extract that, you're going to perform what we call, just ensure that everything is within the same projected coordinate system. So before you now start doing your Euclidean distance and then trying to scale them and blah blah blah. So that's just the explanation of everything. So you can see my built up area. You can see the built up area. The built up area is there. You can see. So one is very bad for doing that particular landfill task altogether. So you can see area here are not good for dumping refuse altogether now. So 2 less suitable, you can see that. So, but what I'm after is the 5, which is what? Highly suitable. You can see that. So you can see all those places here. So all these places are highly suitable for dumping refuse. Each criteria now, each criterion here have its own meaning. But the task you are doing now is multi-criteria analysis, MCDA, decision analysis. Did you get my point now? So that's it. If you're considering only the residential areas, all these areas are good, right? If you're considering only the only the roads, all these light brown areas are good altogether. But you have to join all these things together to now check where's the best location using this multi-criteria decision analysis. So that is the method MCDA. Yeah, altogether now. You can use this for your flood too. You can combine rain or elevation, your slope, what is again? Soil. You get my point? For your flood analysis. Altogether now. So that is MCDA, multi-criteria decision analysis. Considering your rainfall, when you have your rainfall map, based on the map, the symbology, you have where you have higher rainfall, right? So you're able to see this area, we have more flood. You get my point? That is for rainfall. You check your slope. We notice that area that are lower slope are likely to have more flooding events. You check your elevation, lower area are likely to have more flooding events and stuff like that. So now you combine all these things together, you have MCDA analysis. Altogether now. Yeah, so that is all about, okay, I think we still have, okay, the soil data. From the link I stated above, FAO data portal soil. So you can, after clipping from the total study area, I noticed that we only have 4 types of soil within ILE IFE. You get my point? So we have 4 types of soil within ILE IFE, and we have the clay to be less suitable, the clay loam to be highly suitable, and the sand loam to be moderately suitable, and the loam to be suitable. So this depends on your research. You can check, okay, you can ask Google, out of this soil, which one is most suitable for land, filling, whatever. Do you get my point? So it will rank it based on the best one, like the best type of soil. Do you get my point? So that's what I use in arranging all this. As you can see, we don't have anyone not suitable. So we don't have any data here. Assuming we have many more type of soil, we do work for grouping. Let's say we have like 6 and our ranking is 5. You can group 2 together, like maybe clay and loamy. Like, you get my point now, like not to be suitable, so that you can have the same thing as the same ranking system altogether now. But in case it's less than the entire ranking system, you just leave that space empty. If it's less than 5, maybe say 4, 3, 2, 1. Like the data set you want to make it up. Like geological data now, it's only 1. So you neglect that one. That one is out of it. But let's say it's like 3 or 4, you can still make use of it. But you now let us know that it should fall within the moderates and highly suitable and suitable zones. So you neglect all those not suitable and less suitable, because we are not after that. We are not after those zones altogether now. So now that's all. So as you can see, this is the soil. I have my 2. You can see the reclassification here is different. You can see it's in 4, right? we don't have any 1 because our 1 is not suitable here. You get my point? So the 1 here is gone. So we have the 2, we have the 3, we have the 4, and we have the 5 all together. So the data processing. So your analytical hierarchical process will be used to assign weights based on how important one data is over another. All together now. So it tells us how important is them to soil. It's A. It's very important because you can't get slope without them. All together now. So depends on your own brain. It depends on how you want to visualize. Oh, this is the way I want my own to be. My dem to slope is very important. That's why I put A. All together. My dem to river is important. That's why I put A. My dem to road, I put B. My dem to residential, I put B. My dem to soil, I put B. So depending on your choice, you can write AA everything. You get my point now. But depending on what I have, okay, right? I say, okay, my dem is more important to my slope, is more important to river, not that much important to, that's more important, not that more important. That's AP, all together. So you can put the ranking system, the scale, blah, 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 hello, all together. So you can see the graph, the HP graph. It shows that my residential area carries more weight. You can see that now. Residential area, it carries more weight, then followed by the roads, all together, then followed by the rivers, followed by the slope, followed by the dam, and followed by the soil. The soil has the least weight value, all together. Sometimes you can subject all those criteria to have equal weight all together. So that means it's weightless. You get my point now? It doesn't have any weight. Because you're subjecting your everything to be like the same thing. So no difference all together. So the result you're going to have will be different from the results you are to weigh all together. So that's all about that. So this is the chart of the hierarchy, whatever process. So you can see this is my weight value. These are my weight values. I have 12.8 for them, 15.4 for slope, river 16.2, roads 21.0, residential 21.6, and the soil is 12.7. So as you can see, the matrix, engine factor, and then the weighted overlay analysis is performed, and then I have the landfill suitability map of ILE IFE to be this. Wumi, all together. Omoti. All right. So, and now based on my research, I have 1,236 stations within my study area that are best suitable for landfill site selection. Nife. All together now. Stations, like locations. Landfill, like dumping sites. Yeah. No. Like we were unable to see that. Assuming we normally we are considering the highly suitable area zones. You get my point now. I don't think those actually should be among because they are classified under built-up areas. Yeah. It shouldn't. So now let's go to our analysis. So we are done with it. We all understand the introduction of what we want to carry out. Good. Now we'll go to the analysis part. Now the first data to download is what? Like I said, the dam. We are starting the practical now. Yeah. I just did a brief introduction to what we want to do, and then now we are having the practical. Starting the practical. Yeah, of course I have to recap based on the fact that some people are not here, so you get my point now. And we can, those that are here last week, we have better understanding of what we are doing too. I don't know. I'm trying to charge my system. Sorry for the no. It's this. I'm trying to charge at the same time projecting. That's why. So now, can we go to? If you go to your Earth Explorer, if you want to download the digital elevation model, for what's it called? ILE IFE. You notice that there's some parts missing, right? Look at the southern parts. You don't have it covering the entire area. So in that case, let's just forget the fact that we want to use Earth Explorer. We want to use Google Earth Engine. So that's where Adebola, you're listening now.
Yes.
Yeah, good. Now, like I said the other time, the first thing you do here is what? You add your what? Your boundary. You set your coordinate system first. Wale. Yeah. So how do you set your coordinate system? You know that, right? Double click on your layer, go to the properties, then click on the coordinate system, and then projected. And I'll go to UTM, WGS 94, North Hemisphere, and then select 31 knots. Altogether, you can right click on that 31 knots, add to favorites. The reason why mine is not active is because I've added this to my favorite before. Altogether. So if you haven't done that, you are going to have this to be active. Altogether. So click on that, add to favorite, and then click OK, apply. Altogether. That shouldn't take more time. Alright, so now you're gonna add. Now I want to teach us how we can add like a study area based on our choice. Further down, see, you should listen here. This is where you need it most. It's related to our own project. That's what I'm saying. This one of this process, yeah. Okay, right, you're doing it, yeah. Thank you, sir. Now let's assume that you want to do for the entire Osun State. I posted something on my status. I did for the entire Osun State. You're going to merge a lot of things together, but your Google engine will merge everything together. You only get the result for that particular study area and then move on with analysis. You can see it has skipped a lot of process. So that's the function. It automates workflow. So further on, please. We are together. Yeah. So now I'm going to add the entire local government of the Nigeria. Sorry, I will show you that. You don't have a flash. Right, we have a flash. Please send it. So I'll just. So you navigate to OSM Nigerian boundary data. So your level 2 correspond to local government. Level 1 correspond to states. Level 0 correspond to the country. We're trying to add the local government. Sorry. Yeah. Raphael. Yeah, I want to teach us something on how we can select. Like, let's assume you want to start a new job. You know, we're going to download your study area first. Assuming you don't have your study area yet. You know, we are going to have the entire local government of the entire country. Now, how do you not select based on your study area? So that's what I want to do. I want to start from the scratch. Do you get that now? Not that you have the shapefile already. No, I will send it to this flash. You just have the data. Yeah, I will copy everything. I'll just zip the Nigerian data, the Nigerian zip I have. Everything about Nigeria, everything. I'll just zip everything to you. So it's a criminal offense to hide academic. The one here. So this is the entire Nigerian data I have. So I'm going to zip everything I have here. So can we proceed or we just chill? The Nigerian shapefile. Go to your Nigerian data out there. Go to OSM. Go to OSM Nigeria boundary data. Are you there? OSM Nigeria boundary data. Are you there? Yes. Right. Then check that plus button and then go to Nigeria pod admin 2. This are saying yeah, Nigeria. You see, Podna, Plunda, admin, whatever. Are you there? You see admin 2?
Yeah.
Do you see admin 2?
Yeah.
Debola, are we together? Alright. Now, left click and drag this polygon shapefile. We have line, we have polygon. Are we together? We have two feature layer here. We have the line, we have the polygon. So drag the polygon, you're going to have something like this. Nigeria Podna admin 2. Are you under OSM data? OSM data, under OSM data, scroll down, scroll down, scroll down. You see Nigeria Podna admin 2. Are you there? Good. Now click on admin 2 and then check the Nigerian country admin 2. Are you there? Then drag in that particular polygon NGA POLNNDA admin 2. Drag it to the ArcMap interface. Are you there?
No.
What happened again? You shouldn't take your time. Just search for it and drag into your ArcMap interface. That's all. Where did you put your? It's not a matter of where you put it. Once you open that Nigerian data, everything is arranged automatically. So unless you just add the admin 2.
Which one should we add?
Admin 2, the polygon. There's one with line, there's one with polygon. You had a polygon, the polygon. Did you see? Is that it, right? You have the same thing this way.
Yeah.
Something like this, polygon. Yeah, good. So now,
No, the
polygon. Are we together? Now, good. Now, let's ask, you're working on your project, right? You're working on your study area now. Now, ILE IFE comprises of 4 local governments: IFE North, Central, South, and East. Are we together? That is what we know. Now, what we're going to do here is that we are going to perform, are we together? We are going to perform either multi-query analysis. That is, you go to your selection. Sorry. You go to selection. Check or get it. No, color on the issue. Color doesn't matter. Color doesn't matter. You drag it to the map interface. Shown. Includes East, Central, South, and where is it? North, right? Good. Now, that is what we want to query out from this entire local government, 774. Now, you go to your selection tab. Are we together? Fin, are we together? Are we together? Now, you go to your selection, select by your attributes. Your layer to be that particular local government you've imported. Now, double click on admin 2 name. You have it written here. All together. Admin 2 name. You double click on it. You have it here. Equals to. Everything is there. All together. All together. We're not together. Okay. Now, get unique value. Click on get unique value. So it's going to bring every local government. Did you get my point now? So these are to select your study area. All together. Now, so you now scroll down. I'm interested in if East, if whatever, and blah blah blah. So you're going to do it. So you in case you have many data all together, you can go to I. Did you get my point? So it's going to bring Ibadan. This is Ibadan North, Ibadan North East, Northwest. Ife East. Anyone, just pick one first. Just pick one, yep. Just pick the first one, central. Pick the first one, central first. All together. Now apply. Once you apply, you see something selected within an ArcMap interface. Can we see that? Kemi? Can we see Antonia? All together? Alright, okay. So we only can do that. So we now we zoom in, we zoom in, we zoom in, we zoom in, we zoom in. You can see we have Ife Central right selected. All together. Now there's a command to select more than one. Is it or and? Is it and, right? Is it or? Is it or and? But let's try to check it first. Let's check it first. Yeah. SQL. And no, you're not adding any space. Did you see my expression? Or I should just start over. I should start over, right? I should start over. Alright. Let me start all over. Double click on admin 2 name. All together. Equals to. All together. If a central. Apply. You see if a central is highlighted, right? Or admin 2 all together equals to if a east. Apply. You can see that. All together or admin name equals to if a not. Apply. You see that? All together. Wumi? Yeah. Oh wow, that's good. Equals to if a south. All together. So I've selected everything. This is multi-query. All together now. Multi-query, like in the sense that admin 2 equals to ILE IFE Central, or admin 2 equals to IFE East, or did you get my point? So it's going to select everything at like once. So now you can now click OK. So once you click OK, you right click on this. Came here together. Where? Alright. Alright. Now you right click on this layer. Right click on this layer and then right click on that layer. Your selection, and then create layer from selected feature. All together now. So the next thing I want to do is that I want to match all these local governments into one. All together. I want to merge everything here to one. So how do I do that? Just start your editor. Start your editor. Now click on each of these. If you notice that if you are clicking one by one, what's that? For you to select more than one, you hold your shift key on your keyboard, shift, and then you can add, continue editor and continue the editor. That is how to get your study area. All together now. All together. Yes. All right. Yeah, the 4. All together. Now, before you can highlight one, once you click on one, right? If you click on the other one, it won't hold the other one you just pressed. So what you're going to do is you just hold the shift key on your keyboard, which will allow you to click on many shapefile as possible. So hold the shift key. As soon as you're done, it will highlight the entire 4 local governments. So we should stop editing. Chew. Now You want to merge, right? Now you click on this editor and you see the merge tab here. You see merge? You see merge?
Yes.
Now click on merge. It will regard everything into one. You can see you want to merge. You will. Yeah, no, don't worry. Just click OK. Once it highlights everything, just click OK. Did you see that? You see that? So once you click on the merge, you merge everything and then save your editor and then stop the editor. All together. Save the editor and stop the editor. All together. So you can now rename this. You rename this. How do you rename? Double click on this.
You save it.
Rename. We want to rename this. Or ILE IFE. It's no more NGA whatever now. So you have to rename it to the exact. So now I will advise you in your working folder. Are we together? I will advise you EBT DM double at my work lily. You have to listen here very well. Now. Yeah. So now, in this case, I don't want to rename here. I want to export this shapefile out. Right click on this. Don't rename, don't worry about that. Go ahead, it's still the same thing. Go ahead, don't worry. Right click on it. Data, export the data. We want to use this data to download our digital elevation model from Google Earth Engine. That's the assignment. That's the exercise we're working with. Now, locate the folder. Locate your working folder. So I have my desktop, Tonya. No system last time. LANDFILL. You can create a new folder in there. If you don't have any folder, then enter that LANDFILL and then type ILE IFE. Just select your file directory. Save it. Once you save it, then click OK. Now it asks you if you want to add this to the map. Just say yes. So it will add it up. This is ILE IFE, and then remove this one. All together. So this is done for. This is our study area. We just define our study area. Let's go. What is different? All right. Good. All right. So don't forget. Yeah. You can change the color if you like. You can just allow. Change this to allow, and then the outline color to red, and then you can change the width to like maybe 2, and then click OK. You're lost. Sorry. So you're lost. You can watch the video later. So don't forget to save your drawing. My drawing is LANDFILL, right? Don't forget that. So I'll just go to my working folder. Don't forget your working folder. That's desktop. And then my Tony all right. So you now rename this to be LANDFILL. All together. We're trying to save the drawing. This arc map. Have you saved the drawing? You saved it already?
No, I've not saved it.
Then Ctrl S. It should. Then navigate to your desktop, not in arc map.
I know.
Right, of course. Then you zip everything in there. Yep, the ILE IFE boundary. No. This is. Go ahead. So now you just rename this to ILE IFE. Out together. Or IFE. Your choice. So I'll just type IFE. Just zip, click on zip. Zip, just type IFE, zip. Just check on this zip. Out together. Are you seeing what I'm doing? Check on this zip. It's because I'm lagging behind, that's why. Yeah, zip it. Please make sure you zip the entire shapefile, every component. everything there, zip it, and then click OK. Don't worry about the message you got. Don't worry. Just close the box. The reason I get the message is because that shapefile is open in ACMA. Did you get that now? So just neglect that. Fin, all together. Just take it small. You understand better. Antonia, you're following? Good. So the next now is we are going to our Google Earth Engine environment. All together. Now you have to be very careful here. Ask God. We are going to our Google Earth Engine environment. If you have an account, don't forget. But we are not logging in, like we are not signing up any account today. You're just going straight to Google Earth Engine. If you don't have it, link up with someone else, then we'll move on. All together. Right. So this is the Google Earth Engine code. Now, I have different codes. Here. But what I need here is DEM, Digital Elevation Model. All together. Just double click on, like, I don't know how I can put this. I don't know how I can send this code to you guys. ChatGPT, yeah, and hacks. That was very good. You can do that. But I'm just thinking it's going to take time because some people be saying you have different codes and stuff like that. Because, yeah, that's what I'm saying. So, yeah, I have it here. I can just send it in form of a link. So you just open the link on your Google Earth. It will open up straight away. So let me get the link. So copy the link. Fundebola. Now, this is the code for getting the DEM of any area in the world. You just need a little manipulation. And what is the manipulation? Just bring in your study area. That's all. All together. Great. Now, you can notice that what I have here is variable ROI, table user, software BJ Oshun. The last DM I downloaded was for Oshun, right? Now, you zipped a particular shapefile, right? Now, you come to the asset. This is where you import your shapefile. Debola, are we together?
Yes.
You zip your Oshogo. You come to assets, then you click on new, and then import your shapefile. Are we together? Now, it asks you to select the file source. Then you click on the select, and then you go to your folder, and then click on landfill, and then you can see the zip. Click on the zip, and then open it. What is saying? The asset ID already exists, so that means I have it already. All together. So for your own case, you have it straight away. You don't have any information that the asset is already existing, like stuff like that. So once you have it there, then you just click upload. All together. Just click upload. Are we together, iShat? It's uploaded. Have you uploaded it? Yeah. Good. Click on upload. Now, once you upload, now come to your tags. You see a particular settings icon rotating. All together. Once it's marked, that means the shapefile is on the platform. All together. Should mark. What's mark? Good. Now, you know you're under the assets tab here. Now come back to my scripts. The scripts. All together. Yeah, what am I doing now? All together. Kemi, are you following? System it. All right. Now, this is what I'm going to do. Go back to my assets. Go back to the assets. I want to import my shapefile into this code. Yeah. You go to your script, you load your script. All together. In case your script is loaded already, don't disturb yourself. Load your script. That's the first thing. Load the script.
So Sorry, I want to ask.
Alright, what's the question?
How do we load? Is it the link? Wait.
The link I sent.
The link you sent.
Once you click on it, you get the script. So you cannot save it on your own Google Earth platform.
Why? So like that.
Good of you. That's it. Yeah? You see the icon save here. There's a save up here. So once you click on the save, it now asks you what's the name you want to. You can say now how to download them or code to download them. My own is them calculation. Did you get my point? You can rename it to whatever you have. So anytime you want to make use of it, you just come back to your scripts, double click on that particular thing, and then supply in your study area and get your results. That's all. All together. So now, I already have IFE here, so I'm going to double click on IFE. So you say double click on IFE. All together. Once you double click on that,
it's because we had it before. We don't have to do this again, Abby.
you have to. What's the first thing I asked you to do? You insert what? The shapefile. Once you add the shapefile, it comes here.
Oh, okay.
These are all the shapefiles I have.
Okay, so the reason why we are checking tags here, like once it's my damage, it will show you, and it's not match, it will not show.
It will not show. That's very good. That's very good. Did you get that now? Ask about together. Right. So now you double click on IFE, the shapefile you just uploaded. Now click on import. Double out together. Huh. Let me delete this. Just chill. Once you upload, do you have the mark? Do you have the mark already? Now you should have it under this legacy asset. You should have your IFE under this legacy asset now. Do you have it? No. You don't have it? No. You don't have it? Asset. Refresh. Reload this. Refresh. There's an icon for refresh.
I want to try to
Alright. So now once you double click on IFE, it's under whatever asset you have it, and then click on imports. Omoti, are we there? Click on imports. Alright, once you click on imports, I'm having two import things here, right? I'm having two ROI here, two shapefile. I'm having the one for Oshun, I'm having the one for IFE. In between here. You know, I sent you a code. I sent you a link to a code. Yeah. That's for Oshun. You added a new shapefile now. This is it, ILE IFE. So you're having two shapefile here. So you have to delete one.
So you delete Oshun.
So you delete Oshun. So if you click, if you over this particular line of code, you see a delete icon here. Did you see that? Did you see that?
Yes.
Now you click on that, and I say, do you want to delete? You say yes. So I already have IFE now. All together. Don't mind me, please. My system is going down. So now you have to rename this table to ROI. ROI. Region of interest. ROI. Small letter, area of interest, AOI. If you are using AOI, that means your code must follow that AOI. Case sensitive, you are very good. ROI, you type ROI in there. Where you have your table, you have ROI. Are we together? Are we together? So once you do that, just click run. You can see that's the only changes you just made. Are we together? Now run it. What do you have? Run it. Oh, have you run it? Did you see that? Kilometer run. So that is the digital elevation model of our study area. Now, how do I check? You can see. Okay, what's the question?
This that
Yep.
bringing that what did you do to it?
The line of code is having issue. I have to delete something. Insert in line of code here. So I have to remove that thing. Sorry. So that's the problem. But once you save it now, that's the exact code. So you don't need to tamper any code other than to insert your study area. Are we together? Study area, look at insert by. Are we together? Now, now click on this layer. Did you see the layer here? Yep. Are we together? Now, click on the settings, the setting icon here, and then the custom. Click on the custom. Good. Now, apply. Did you see now? Should you put scroll on black? Let's go. Should you put scroll on black? Anyone? But check. You can take your 98. All together. So that's how to download the distribution model using Google Engine. So make this to be 98 and then apply. Then you can close it out. Just close it. So once you close this, hello, are we together? Once you close this, now we have Inspector tab, Console tab, and Tax tab. Are we together? If you're having any error, it will tell you here that something is wrong with line so. Do you get my point? Your console is where you have your maybe graphs, charts, whatever. This is where you have it. And the results is under the tax. This is my result. You can see my DEM is out for analysis. Out together. So you now run this. Run. You can see? Let's go. Don't take us back. Where do you get it wrong, Kemi? Check the video again. Check the video again. DEM. Now you run that. Once you run that, you have this, and then you now rename this to be IFE DEM, whatever. Out together. Huh? Now I'm just trying to visualize. It doesn't have any effects. Don't import. Just apply. Don't import. Just apply. Just to see like it's not a single panchromatic what's it called imagery. Out together. Import. Did I ask you to press import? Now go back to your line of code and delete whatever you have in there. Yeah, what's that? Yeah. Now it's not yet done because it's still loading. Out together. Out together. So it's not yet done. It's still loading now. Yeah. Yeah, no. Once it's done marking like on the Google Engine, just refresh your drive. Refresh the drive. So you have it. So it's marked already. It's marked at 2 minutes. So you go back to my home and then you refresh this out. Yeah. No. Drive straight away. That's all. Go and download straight away. Don't disturb yourself. So I created this 5 things. So this is the DEM. So you can download this. All together. Click on download. So once you download that, the download will initiate now. It's waiting for my data. Blah, blah, blah. So that's the DEM. And then start download. All together. So we are done with the downloading of the digital elevation model using GIS. All together now. So, so basically, I can change the code. Bring my DEM into my working folder. So I'm going to locate where I downloaded that, the file where I downloaded the DEM to, the file where it's saved to. So this is it. So I'll just cut. I'm going to cut this. cut this and then go to my working folder. Tonia, blah blah blah. So go to landfill and then paste inside my landfill. Are we together? That is the dam of my study area. Are we together now? Right. It should get should to get to them, yeah? Should to get them, yeah? Good. So we are going to say bye-bye to Go-Get Engine now. So, but make sure you save that code in case of next time. So next time like that, you just bring in your study area inside and then rename it to what? ROI. Don't forget that particular and then run, go to your drive, get your thing, further your analysis in your ArcMap environment. So that's all. So thank you, Mr. Go-Get Engine. So now we're back to our ArcMap environment. Out together now. You can see everything is like a process, step by step. Now we are back to the shapefile. I'm trying to bring this down so that we can see everything all together. All right, good. You can see that. Umi, out together. All right. So now I want to add my DEM. You know how to add data. I've taught you that. How to add your data. You didn't come during the first class now. Yeah, you didn't come. Yeah. All together. Add it. Ask go all together. So we should be on the same page now. So add it. Once you add it, yes, click on the pyramid. Yeah, good. And then you have the dam within the study area. Did you see that? Yeah. All together. But you notice that there's a background color here. Did you get that? So we have to clip this out. We don't need it. We don't need all this background. So you search for the tool called clip raster. Clip raster.
What if our own did not have
It will.
Our own does not have
You have the demo already. You didn't download the one from the Go-Get Engine.
No, you know, not checking media and things you had.
Okay. Oh, to register. Okay, all right. So just make sure that the dam you're using is within the confined boundary. All right. Okay, that's good. So right, input your dam. Bushima Shelile you, Debola. Bushima clip raster. Yeah, of course. You clip your raster. Ask about together. Are we all together? Now, the output extent will be my digital elevation, my ILE IFE, because that is the extent I want to clip my dam with respect to. Now, don't forget to check this. Use the import feature for clipping geometry. So it's going to clip with respect to the edges of the boundary, of the boundary of our study area. And then just leave everything by default. Understand? Leave everything by default and then click OK. Leave it. Out together? Yeah. You're right, Shannon. Out together, Finny. Are you getting this small? Are you getting it? Yeah. So it's clipped already. I have it clipped. So Debola, do you have on the same page? Alright. Now Ini on the same page. Sobawale, same page. Aisha, that's good. Pastor John, Kemi, let's go. Alright, Kemi, why are you not talking? So you can remove the what's it called? The demo we downloaded at that time. We don't need that anymore. We just need the one clip to your study rate. All together. We remove the background value, which is 0. So now this is the dam of our study area. All together. Now we have the dam. What other data do we need for this landfill? Slope. Did you remember? Yes. Now you now search for the processing tool called slope. Search for slope, S-L-O-P-E, slope. Are we together? Now, surface, slope 3D analyst. Click on that. You click on that and then input slope 3D analyst. Then input your raster, leave everything by default in degree, leave it, and then click OK. Debola, are we together? Mike, where you want to put it through? Blow it out.
We are not changing the output raster.
Just leave everything by default.
Don't
Don't stress the same. We have the dent, we have the slope. Now remaining the soil. We need to bring in the soil. Go back to my Nigerian data, and then you see file word soil data. Have you seen it? Check the file word soil data plus sign, and then you see something DSMW. Did you see that? Check that, and then bring in the DSMW.shp. That's what we are bringing in. Just drop it in. You see, it said unknown .shp. You see, unknown reference. Are we together? Debola Tobatishe, check more.
Yes.
Alright. Now click OK. We don't have anything, yes or no, right? Good. It's because there is no coordinate system appropriate for that. The reason foul soil. Out together, we have to be very careful here. We inserted a foul soil, but we don't have anything on the map. Out together. Do you have anything?
No.
Good. Do you know the reason?
No.
It's the same thing. The reason is that your word projection coordinate system don't follow you. Your word is WGS, but we are working in what? Projected zone. That's the difference. All together. So what I would advise you is that you should open a new ArcMap document. Go and prepare your soil data first. All together. And bring it back to the projected system after you're done clipping with your study area. This is datum conflict. We don't have it to be projected. But let me see whether there's a solution to this. Search for projects. Projects. Did you see that? Projects. Project. I said projects. Projects. There's a difference between projection and projects. Now, click on projects. Now, bring in the DSMW, the soil data. They will allow it together.
Error.
So you have it to be error, right?
Yeah.
Wait. Where do you get lost? Where do you get lost? Project. PROJCT. That was it. Yeah. You have this. Are we on the same page? The same page? Alright. Ask God, are we on the same page? Good. Now drag this DSMW in. We have an error. Because the coordinate is what? Unknown. Define the coordinate yourself to be what? WGS. Not projected because it's a word soil data. Now, this is where you define the coordinate. Please watch this thing very well. This is where you define the coordinates. Click on this tab and then show to WGS 984. I told you to watch this. If you don't watch it, you'll be lost. Check this. It's unknown, right? Check this icon. We want to define the coordinate system for that particular shapefile. Altogether. Now, search for WGS 984. Did you have it? Not projected though.
Not projected.
If you do projected, you start all over. Normal WGS 984. Altogether. Geographic coordinates. Okay, you didn't have it on that favorite, Abby?
Yeah, I had it, but it's not sure. Projected one.
Geographic Luma Lotte. Well, alright, boss.
Okay, so under the geographic, I click on
Word. Okay, let's navigate through it together. Click on geographic. What? WGS 94. Did you see that? Now click on click on it and click OK. Did you see that? I don't have error again. There's no error again, right? All together. All together. Now the output coordinate system. All together. Make it WGS 94 also.
Which one? Output coordinate system.
WGS 94. Do the same thing. Now click OK.
Okay.
Yep, okay. Projection, of course, big problem.
That one.
Did you see that? I have something now. Did you have something?
Yes.
You do, right? What is the issue?
Ozone.
What we do here is that we're going to clip. You can move this. You can remove the first one you inserted. That one doesn't have any coordinate system.
Which one? Okay.
Remove that first one. Now, this has been projected out together to the WGS 94. You can see, if you uncheck this, you notice that if it's bent, this is that you can move it down. That is layer order. You can hold it and drag it down to arrange the order. Click on this. You see that? You can see if it's on this, right? Uncheck your dam. Uncheck all this. You see that? So I have 4 soil within. I can see that already. I have 4. I have 1, 2, 3, 4. But don't be confused. Now the next thing we're going to do is to clip all together. Tí o bá yẹ sọ̀rọ̀ Faransé. Tí o bá yẹ sọ̀rọ̀. Àwọn àṣà. All together. Now search for clip. Good. Clip raster. So you have clip data management. Are we on the same page? On the same page, you have to be very fast. How to get a follow step by here, let me know. How to get aspect them to follow for shit. Now we are back to landfill. How to get it now? So we should go. Kemi, show you. Right. What to get away? Now, good. Oh, sorry. The clip we are to use is not raster, ordinary clip analysis. Because we are dealing with vector and vector, not vector and raster. All together. So it should be clip analysis, not clip data management. All together. Now, insert input feature to be DSM project. Nǹkan tó fẹ́ clip ló máa kọ́ jẹ́ first thing. Area ibi tó fẹ́ clip ẹ̀ ló máa jẹ́ second. Are we together? So leave everything by default. Click OK. Leave everything by default. Click OK. You don't do right? Good. Now you can remove. Yeah, the project. Yeah, good. So you can see I have the soil for IFE now. All together. Now, if you check the attribute table, for this, you notice that they are written in numbers. SNUM, soil number. All together. Please, you have to concentrate this here. S no, soil number. We are going to interpret this number to the exact soil type. But before we get there, all right, we have to project this soil. If you could recall, this soil is in WGS 924. We have to bring it back to 31 knots. Remember, everything must be to the same projected coordinate system. Your DEM, is it projected? Check it out. Your slope, is it projected? Your soil, is it projected? So you have to check everything one by one. All together now. All right. Okay, that's good. All right.
What's the difference between the clip analysis and the
Clip data management raster, clip analysis vector. That's the difference. Now, search for projects. Projects.
Wait, we should close down attribute table.
Search for project.
Take maybe the question.
Or you can ask question. Okay. You can ask question. Don't worry. I can answer you. Don't worry. Okay, right. Now we have. You can see the default coordinate system is what? WGS 984.
When you see clip project, data management,
Clip. Ebola and clip.
Project person.
Yeah.
Click project.
Yep.
data
Project.
management.
Yep. All together. All together. We are taking this thing one by one so that we understand. Now, the output coordinate system to be. Please don't go and take me now. You're on your own. WGS 984 UTM zone 31 knots. All together. Now, that's how to project. You can get a job. I want you to project this vector data from geographical to projected. They can pay you $10, $20.
Oh, how do you do
Eh?
that? Oh,
Do you know how to do it? Oh yeah, I'm learning. So that's it.
wait,
Zone 32.
32
This 31.
I'm actually saying 32.
I said click on WGS 9084 UTM zone 31 north. Don't worry about what you're saying. Just understand the concept. All together. Adebola, all together. On the same page, click OK. So you can remove that other one that is in WGS 984. So leave everything in projected. So this is the soil. You can rename this to soil. Soil. SWAT 2012. All together. This access file. Open it.
The soil with
SWAT. Did you see SWAT 2012? File soil data. We want to interpret that as norm. Please show it up.
Okay, so 22.
Yeah. Access, open it. Open, don't waste time. I'm sorry. I don't like it too. Let me get. I don't like people shouting at me too. All together. On the same page. Aisha, on the same page. Alright. Shut the open order, you know. Alright. Now, search for user soil. User soil. Search for user soil here. User soil. Or soil user. Okay. I've seen it. Have you seen it too? User soil. Now double click on it. So you can shutter bar, close this shutter bar. Close that. Now,
User soil default.
user soil, double click on it, then you have something like this. All together. You have something like this. Show the user soil only. Double click on user soil. On here now. And you are still now surprised, I see. Now. Now, did you see? Click. I'm trying to locate which column is having that. See this? Please go back to our soil. ArcMap. Go back to soil ArcMap. Double click on it. go to the symbology, categories, S norm, if I rush. Are we on the same page?
Yeah. I got it.
Symbology.
Hello, are we on the same page? Now add all values. Did you see all those numbers? Did you see all those numbers? Yeah, alright. Click OK. Did you see that? Hello? Are we together? On the same page? Stop talking, please. There is no time. Please stop talking. Please, please. We are not after color.
If I want to change the color, but I
Forget the color for now. You
like, I
know,
want to change the color.
Auntie Wumi, please. Please. Now, add a new field. Call the field. Right. You got it to this stage, right? Double click on this soil. Go to symbology, categories. Did you see categories? Click on it. Unique value. Click on it. Your field value, S norm. All together. S norm. SNUM. Are we there? Right. Uncheck this all other value. All together. And add all values. You have 4. It can be of any color. Are we together? Alright, now click OK. Are we on the same page? Now, right click on the soil. Open the attribute table. On the same page, Wumi, on the same page. Open the attribute table. Add a new field. Call it maybe the soil name or soil texture, whatever. But I prefer to call it texture. Texture. Soil texture. So it will be in text because I want to type. I want to type whether it's clay, whether it's loamy, whether it's whatever. All together. So you make it text and then you click OK. Once you click OK, further all together. So you can drag this, it's on the last column. Text, because we want to type alphabets. Now drag, click on this texture straight to the last edge. Click on the texture and drag this texture, drag it, just hold it and drag and drag. You can see it's I'm trying to drag it, changing the column position. I'm dropping it beside my S norm. Did you get what I did? What I did is just normal Excel, whatever. Wumi? All together? Alright, good. Now start your editor. We want to add the name of the soil texture. Start your editor. Click on the soil. You should be clicking like that. Pa, pa, pa. Oh yeah, all together. I shot. What's on? So click on the soil. Start editor. Click on the soil. Finish. Sorry, okay? You can watch the video again and understand. You understand better. You get. At least you are gaining some little things like. Start editor. Yeah. Click on soil. Then click OK. All together. Now let's go back to our Microsoft Access. So we want to know all these S norm. We want to check those numbers, what they correspond to. Did you get the purpose of that access now? Right. Now go back to access. Find what's the first number? 1277. Find. Did you see that? Okay. Let me teach you how I did this. Okay, are you here on the same page, right? Click on this sequence. Click on the sequence. What is that? Show it open. What will user soil? Show it already user soil. Sequence. Click on the sequence. Now, on the ribbon tabs of your access, you see find. All together. Please don't teach them something else.
I'm not the one teaching
All together. Click on the sequence. Now click on find. You should have the same thing like this. All together. Now, what is the first number in your ARC map? 1277, right? Now find 1277. Find. You see, I have it there.
Okay.
What's that?
I see.
Now copy that standing loam. Copy the standing loam, or you can type. If you want to type, you can type. I don't like typing. Copy, then come to my GIS and paste standing loam. You can remove the underscore. I don't like seeing the underscore. All together.
You copy it by the first texture.
What is the S norm of that first texture? We get it? We get it, forget about it. We are trying to populate that soil data based on their S norm so that we're able to identify which type of S norm is corresponding to this type of soil texture. All together. So that's the purpose of that access. All together now. Alright, now we can find 1487. What is 1487?
1487.
Good. Click on the sequence. Find 1487. 87. Find. I have clay loam. Copy. Should I click on the sequence? Should I highlight the sequence? I go to find. That's good. What is the name? What is the?
1487.
Yeah, we should have the same thing. I have clay loam. So that's how to prepare your soil. That's how to prepare a soil map. The next one is what? 1588. All together. So before you find, make sure you click on the sequence column. All together. Click on the sequence column and now find. What is the value? One word. 1588. Then find. I have it to be what? Clay. Yeah, just copy everything you see there and paste it in your ARC map. All together. You've done everything. That's very good. Nice students. Now the last one is 1583. 1583. Find. It's loam. You can see how to prepare soil map now. That's how to prepare your soil map. Now copy that. Come to my ARC map. Then paste.
This one is clay. Ordinary clay.
Sorry, let me make a mistake or what? 1583. 1583 is loam. Right? Clay, yeah, I made a mistake. We're doing like copying and paste. Fin, are we together? Alright, good. Now after you're done, as you know, we have to what? Save our edit and what? Stop the what? Edits. So I'll just go to my editor, save, and stop. Will you hear me? You can see that? Are we on the same page? So this is preparation of soil map. So you can use this method to prepare soil map of any area. So you can see we are working on each map. So each map will now be overlaid together to get the landfill suitability site selection we're working with. All together now. So we are preparing different maps together. Elevation map, slope map, soil map, road map, river map, and everything like that. So we now combine all these things together to give us the landfill site suitability map. All together now. So we are done with soil. All together now. So we're done with soil. So now click OK. We mean all together. What's on? Okay. Now we are done with soil. The local law. Get the concept.
I cannot do the color I want.
Ṣé kí ló fẹ́ fi kọ́lọ̀ ṣe báyìí?
Kò sí nǹkan tó kẹ̀. I cannot do the color I want.
Ṣé báyìí ọlọ́lọ́ pink ń gbà ẹ̀?
I want to use it to pink.
Kí ló fẹ́ fi kọ́lọ̀ ṣe báyìí o? Now, the next data set here is what? River or roads or... Do you get my point? Do you get my point? So we need the river data all together. So go to my Nigerian data all together. Now go to IFE. You see, look, shapefiles. No, not this. Planets. There's a particular one. Planets. I'll show you. Copy it. Oh my God.
Only I'm lost to.
Ibo ló ti lost báyìí.
Ibi tó ti lost yẹn náà ni.
Ẹ mi náà ti ṣe gangan. Nigerian data. IFE. Check the IFE, right? Under IFE you have them. You have IFE again. Check that IFE again. Did you see planets? Now check that planet. Shape. You see all those pictures all together. You see building, land use, natural places. All these were downloaded from this reference link I talked about the other time. So we can't be going there and be downloading anymore. So we already have the data. So if you want to download, put find link here. So what we are going to bring in here is just your river and what? Road. That's all. Just bring waterway and road. Old sheet. Can't I select many things? Okay, right. Just drop them one by one. Don't forget about dropping multiple. Oh my God, it's not sufficient. This is not the one I'm looking for. Yeah, it's not sufficient.
What am I adding? Is it everything?
Like, what are we doing to add? Is it?
We're trying to add waterways and road, but the road here is not sufficient. That's all. I'm trying to add. To update, can you read it now? Thank you. We're trying to add rivers and road. Yeah. River and roads, and then we have to continue the rest this week. Waters and roads, yeah. Yeah, after that we stop. So from next week we are going to do land use land cover so that we can extract the built-up residential area. So that's what we'll do next. Or maybe I can just do the video if I have time, I'll do the video during the weekend so that we'll do something new next week. We mean boy.
We have to get
Yeah. North. They are in WGS 984. So you have to project that road 31 north. I'm trying to look out for my own road. I have a lot of share. I don't even know where to go to. that. So you want to add the roads and the river. So there is the road. Good. That's the road. So this is the waterway. So you can see the road and the waterway is included. So the next thing is to do what? You project. That's projection. Project your road and waterways to zone 31 knots. So that's what we quickly want to do. 31 knots. So 31 knots. Just click OK. So water projected. Then let me quickly search for the project of the. Yeah, watch the video. Don't worry. Then I'll drop the roads. I don't know why it's taking time. Yeah. We're going to shit on that. So waterways has been projected and the roads projected. So roads are projected. So remove this. Stop.
I believe this board is
So now, if you're performing your Euclidean distance, hello, learn something. Your Euclidean distance, Euclidean distance. Sorry. Now, hello, if you're performing these geoprocessing tools. Are you listening, please? Alright. Now you drag in your road project to leave everything by default all together. And then the reason why I don't want to use environment is because we are yet to perform our reclassification. So I don't want to use environment. So you leave it by default at first. Did you get my point? So perform the Euclidean distance by default without your raster analysis. You have to uncheck it. Do it directly. So that's the Euclidean distance for the road. It's working on. So it's when we are doing the reclassification, that's when you make use of that environment. So the classification must not pass beyond this study area. Did you get that? So Euclidean distance, that's the Euclidean distance for the road. Now for waterways. So leave everything by default. Just leave everything by default.
Why did not do the environment?
No, not yet. The environment will be done during reclassification. Are you sure then? No, don't do reclassification. Just leave everything by default for now. So we have the Euclidean water and Euclidean road, right? When we are trying to do the reclassification, that will be next week. Understand? So when we're trying to do the reclassification will now be with respect to the environment. You can uncheck it, you can redo it later. Did you get my point? You can redo this, just do your Euclidean distance, you can leave everything by default and leave it. So we have the Euclidean distance for water and the Euclidean distance for the road. All together now. So once you have that, next week we'll do the reclassification, then it will now be with respect to the study area, and then we'll carry out the land use land cover to extract our residential areas so that we can perform Euclidean distance also for that one too. Did you get my point now? So we can now deal with the reclassification, and then we talked about HP, assignation of weights to all those criteria. Yeah, we're going to like a recap of everything. So once we do that, then we now use the weighted overlay analysis that allows us to overlay those rasters on each other, and then with that we can have a landfill site suitability map of LANDFILL. So that's all. Thank you so much.